Hello. Thank you guys for coming. My name is Vlad, and I'll talk to you a little bit about the Spaceship demo and some of the effects that we've created within it. Just by a show of hands, how many of you have seen the Spaceship demo video? OK. That's exactly in the middle. I was hoping it overwhelmingly everybody or nobody. So I'm not going to play it, just not to spend too much time on that. But for those who are confused what this is, please check it out after that. So we have only about 20 minutes, so I've sort of identified a few different effects that I'll discuss, but we'll also keep it very open. So if you have watched it and you want to actually know how a particular effect was done, please let me know and we can explore this on stage. So the first effect we'll take a look at will be the sparks within the visual effects demo, specifically to talk a little bit about spawner chaining and how to actually bind multiple positions. So with one effect, you can simulate something in numerous places. Then we will talk a little bit about sort of the flagship effect of that demo, the pin screen effect. And in it, I'd like to discuss how it was achieved using multiple outputs and how to use custom attributes. And then the same effect sort of transitions to this alert effect. And on it, I'd like to discuss mesh outputs and how to use nested effects, because from 19.2, we added subgraphs within the visual effects graph. So please bear with me. I am running a chunky demo on a laptop, but I'm very hopeful it will go well. At the end of the presentation, I'll also provide a link. This project is fully shared, so everything you see here is available to download. There is a very, very helpful blog post that my colleague Thomas Isch made, and it really goes into full explanation of everything that we're going to discuss here. So once you open that project, it comes with a very helpful navigation screen to allow you to sort of cycle between all the different elements. It has information. You can select the visual effects, the game objects associated, etc. As I mentioned, I'd like to start first with some of these sparks. So we have them already open here. I'm going to select them also here. So you can see that there are a few different effects here that are throwing sparks. However, later in the demo, for those that have watched, a bit of spoilers, I apologize, the ship gets attacked and then sparks start spawning from different locations. So if you have used in the past the built-in particle system within Unity, you probably would have had to instantiate a particle system at every place where you wanted that effect to spawn. So the really nice thing about the visual effects graph is that it kind of goes beyond just being a particle system. It is an actual visual effects system, and that allows you to think more creatively in certain areas. So the visual effects graph comes with a built-in tool of parameter binders. You can see this script here. And you can add numerous things to it. So if, for example, you don't code yourself or you don't necessarily want to go into coding for a particular effect, but you do want your effect to be interacting in some way with the level, with the environment, with the character, then you can use these bindings to send data directly to the visual effects graph. The way you would do that is within the visual effects graph, we have, similar to shader graph, what's called Blackboard. This is the place where you can add different parameters and you can expose them. Once they are exposed, they are visible in the inspector and they can be modified outside of it. So here we have things like count, position map, direction map, the bounds are exposed, etc. So what the multiple position binder does is when you select it here, you can specify any number of targets. And then this value here will be mapped to a value called count that you have exposed here. You can literally name this anything. You can create any other variable. As long as it's of the same type, in this case an integer, then it will be available to be selected and exposed here. So in summary for this, make sure that the names that you use for the binders, so count here, direction map, position map, correspond to what you have called them in here within the visual effects graph. And what it actually does is it's actually creating a texture. So it's storing for each position a pixel, and that pixel with RGB value, it's sorting the XYZ position of where that particular object is that you're referencing. It does similar thing with the direction map, so it knows what its orientation is. So in this case, we have one effect that once the spaceship gets attacked, will simulate in 18 different places. This is really powerful for a number of reasons. First of all, if you want to make any change to this effect, you don't have to go back and individually change all of these. You don't have to work with prefabs in this case. It is literally one single place. The only drawback, and it is important to mention that as well, is the bounding box. So if you have these 18 different effects spawning, really coming from the same one effect, then that one same effect needs to encompass all 18 positions. In other words, the bounding box needs to encompass all of them. Otherwise, if you're outside of that bounding box, even if you send the position to be spawned there, then it's basically not going to be seen. I assume some level of familiarity with the visual effects graph, but I just want to point this out because on the forums we usually discover this is one of the first things that people might bump into as an issue, and that is my effect doesn't appear, or if I move the camera, it disappears somewhere. Within Initialize, you have the bound setting here. What Thomas has done is he has actually exposed the bounds, so he can set them in the inspector, but make sure that whatever this position is, this bounding box, is visible by your camera, and it encompasses all these effects that you are actually touching here. So the other thing I want to mention is spawner chaining. So I'm going to just create on the side a simple empty particle system, just so you see what the usual flow is. So within the visual effects graph, we spawn particles in the spawn contextual node. This basically says how many particles will spawn this frame. Within Initialize, we set their initial values, very similar to the start function in C#, if you will. Update is where you usually do things that have to change every frame, collisions, turbulence, things like that. And output is where things are being rendered. However, you can actually do what we call spawner chaining. So in this case, one spawn can trigger multiple spawns, and you can even trigger not just the start, but the stop of individual spawners. So this is a way to build more complex behavior. So really, if you see here, there are 3 separate effects within this one spark effect. But instead of having them broken into separate scripts and having them to actually reference them and send different kind of events or callbacks or anything, they all reside within the same visual effects graph, and you can trigger them once. They'll trigger this one here, and then this one will trigger this effect, that effect, and this one will trigger this effect over here. So the level of complexity you can add is really scalable based on what your needs are for this particular visual effect. So we're going to move next to the holo table. And this is a very, very interesting visual effect, mainly because it also looks like it's simulating a lot of geometry. Right? You can see all these cylinders here. So I'm going to start opening it because my laptop is not the most powerful one. And what I'd like to discuss here, a couple things. The first one being using multiple outputs. So we just discussed how one spawner can actually trigger different initialize or even different spawners. But you can also do something else which is really powerful. Once you simulate something, so we're spawning particles here just like before, they go in initialize, then they're being updated. But from the same data that you've calculated, you can branch out and do different rendering. So what is happening here is, for example, we don't actually have cylinders because that would be still quite expensive. You can simulate this with mesh particles. The visual effects graph supports that, but there's no reason to do that. You can do this a lot more efficient. So what is actually happening is Thomas here is spawning basically quads with a normal map, and on top of them he's putting little circles. And I can demonstrate this by actually removing the size of the circle. So it gives you the illusion that these are really cylinders, but they're really not. And the powerful thing, as I mentioned, with having multiple outputs, is that at this point we have, so where these lines are here, you have the same data coming out of update, but then we can decide what we want to do with it. So in this first example, we are using a dot circle, basically texture, just a little circle texture that is being masked, so alpha clipped, and then it's being oriented to face upwards. Its pivot is changed a little bit, so it will always show up a little bit above the actual stretched quads. And then the scale is set. You can also kill particles off. So this is really nice. In a way, you can still simulate, but turn the renderer off. So you're not actually killing the particle. To explain this a little bit more, the data usually flows from top to bottom. Spawn sends one way data to initialize. Initialize sends one way data to update. Update cycles between itself, and then it only one way goes out in output. So if you can simulate something that says, and I'm going to gesticulate here, that your particle is here. Up at the end of update, it says it's here. You can have one output that says, actually, it's here. Another output says, actually, it's here. But you're still using the same initial data with +1, +1, +1 anywhere else. So it's really powerful because you don't have to recalculate these things. So the caps, one example here, we have the actual lines. And even though we're talking about flat geometry, that doesn't prevent us from actually having it lit. So we're using lit outputs. Connect target is one of these a little bit more advanced blocks that I encourage you to explore and play around with. What happens with connect target is you can actually stretch one particular particle from where it starts and tell it where to end. So instead of just manually setting a size, you can set a dynamic size. And when that dynamic size moves, like they do over here, the particles are constantly changing their size, it will always stretch up to meet that desired goal. And another powerful thing here, there are some light rays you can see. They're not for each particle. So this is also a little bit expensive. If you want to do multiple outputs, in general, if you have 1,000 particles that you're simulating, every output will put 1,000 things on the screen. But what you can do, however, is you can also set some of them to not be alive. So when I mentioned you can cull particles, if you set this alive flag to false in update or in initialize, it will just kill off that particle. It will no longer be simulated. But if you are doing it in output, because as I mentioned, this is a one-way street from update to output, setting it to be dead, basically, in the output does not affect the particle in update. So next frame, it will still be alive, it will still send down here, and then the output might still tell it, no, I'm not going to render you. So you can dynamically toggle whether a particle will be rendered or not. So what's happening in this case, Thomas basically has certain conditions where he wants to not have all the rays visible, so not to have a separate ray coming from the top connecting with every single cylinder, but just to have a few of them. So the powerful thing you can do with these multiple outputs is that, yes, you can use the same simulation data and render it multiple times, but also you're not bound by having every single output render every single particle. And next, let's discuss the alert screen. This is a bit more of a simple effect, but it introduces a few really interesting concepts within the visual effects graph. As I mentioned, this is not just a particle system. So I'm going to just open the main one over here. You can include multiple effects and put them together. As I mentioned in the beginning, within 2019.2, we introduced the concept of subgraphs, which has been available within Shader Graph, if you're familiar. And what you do with subgraphs is that you can actually grab numerous items, right-click on them, and convert them to subgraphs. There's 3 different types of subgraphs. And what a subgraph does really is it puts things together. You can expose what information you want to be input and what information you want to be output to really not render all these nodes, to clean up your graphs, but also to create custom behaviors that you use very often. So one thing that we don't ship with, but I personally use a lot with my effects creation, sometimes I need a random vector 3, right? You have a random node, so you could just go and say, okay, well, I need a random number. But very often you might say, well, I need a random vector 3, so I have to create 3 of these, change the seed, so everyone will not produce the same result. And then I have to say, well, then I need to append them to create a vector 3. So for example, if you want to do something like a random position. And then I'm going to go like, well, maybe I want it to also go backwards. So I'll do -1 to 1 as a range. And then often you say, well, that only gives me something from -1 to 1 on each axis. So then maybe after this, I want to multiply it with some other value here. We can just change this to magnitude. So something like this is a prime candidate to turning into a subgraph, because then I can just grab all of these, right-click to subgraph operator. It creates an asset. And then when I go within this asset, I can basically say, do I need any inputs? And if not, I can just get an output on it. And then I can use this to create something that I usually do often. So I very much encourage you to explore subgraphs. So back to the actual effect here in place. This was one type of subgraph you can do. But other types include actual effects. So you can literally just have a visual effects in your project folder and drag it within another visual effect. So both of these are actual visual effects that are residing within a project folder. They're independent effects authored, but then you can say, I want to expose maybe timing, maybe size, maybe something else within that, and combine them together. This helps for numerous reasons, because you can first create building blocks within your visual effects library, if you will. Maybe you often have sparks, but maybe sparks come from hammering a hammer on an anvil. Maybe they come from some explosion. So you can create one spark effect and then keep reusing it in all of your visual effects and just expose the parameters that you need to customize that look. Another thing to mention is that you can also make blocks into subgraphs. So to demonstrate this as well, if you have, let's say, initialize, and let's say that you always do the same things here. You maybe set color very often, you set lifetime, I don't know, you set size. The things that you do very often, you can also grab these and in a similar way create a subgraph block. All the subgraphs exist as standalone assets. So again, you can make a package out of them, you can share them between your team, and everybody else will have access to them. And the cool thing is that they also become available in the search menu. So if you create something, you name it something, then you can look for it, and it will be available here. So with this particular effect, a couple other things I want to mention. We are using what we right now call static mesh output. I believe we will try to rename that to just mesh output. Imagine an effect that maybe has some kind of explosion, and you have a custom shader, and you have a sphere inside that you manually resize. Things like this are very common when you create visual effects, but the challenge with them is that you can almost never just automatically integrate them with your particle system. You always have to have some script that is controlling it, that's setting the size, the timing with it. Maybe you're animating it with timeline, maybe doing something else. What you can do with static mesh outputs is that you're literally just adding any mesh. This has nothing to do with visual effects. Any mesh you have in your project, you can basically just add in here. And you can also add any shader. So in this case, there's some kind of sort of simulated redness here shader, but you can add anything on top as well to add, again, not necessarily number of particles, but to add a single game object without having to pay the cost for having a separate game object. And the power of that is that you can also animate things from within here. So if you have something within your graph that is actually being moved about, then you can just add it in here and have different parts of the visual effect talk with it and affect it. It also accepts shader graphs. So the really powerful thing is that all these pieces of Unity are coming together and being integrated. So if you have somebody that is creating a very custom look for something, in this case, this is the shader graph asset. Let me just open it up a bit. Yeah, they're using the unlit master node, they're putting different functions on it, but this is something you can literally just plug in here and work with. So a few other things I'd like to mention. We have events, start and stop. This is sort of, again, the bread and butter. You can make a particle system not automatically just spawn. You can actually plug in. I'm going to start here a new thing just to keep it clean. So if we set a spawn node, you can input what event you want it to actually trigger everything that goes from under it. So the way that works, you can name this absolutely anything. Plug it in, and you can do the exact same thing with stop. Plug it in as well. And you can call these via script. You can integrate them within timeline to have timeline call these. You can manually trigger them, or you can even set what is going to be the default event name, that will trigger this effect. Usually it's on play for starting and on stop for stopping. But the point is that there's a lot of customization going on. This is sort of the main parts that I wanted to discuss. I'm just going to open this and see if there's anything else that might be interesting to mention, because we have a few more minutes. But let's see. So this is a good example of using meshes, not just for the spaceships, for the planets as well. We have the, let's see, the landing site here, wreck bridge. We've added distortion outputs as well to the visual effects graph, so you can spawn maybe fire, and as we discussed with multiple outputs, have a separate output for the same particle that is actually just doing distortion. So since 19.2, which is what this project runs on, we've introduced a bunch of more concepts. There is a separate talk tomorrow where I'll discuss the new things that are coming in 19.3, including motion vector integration, including also what subgraphs we discussed. We have experimental shader graph integration within actual visual effects, so not necessarily just as static meshes, but in the outputs you can create custom look of the output of the particles. And we added a very experimental trails, ribbons simulation as well. So that's sort of running out of time here. I'm going to go back and give you the link. So you can download the whole project. This link is also available with a blog post that explains everything that we just discussed and a little bit more. If you have any questions, my email is down there. And we have a few minutes. We have 5 minutes to take some questions right now. Yes? Can you do this for 2D? We don't have a dedicated 2D renderer. So the VFX Graph right now is mainly targeted with HDRP with some limited integration within Universal. The idea would be that maybe the 2D can actually work with us to actually expand this a little bit. I haven't tried it myself, to be honest. My focus has been mostly on the HDRP 3D side. Any other questions? Awesome. Thank you guys for your time. Have a good day.